Odd even rules of nuclear stability. A survey of the naturally occurring stable nuclides has found that nuclei containing even number of photons and even number of neutrons are much more common than others. Nuclei with odd number of protons and even number of neutrons and vice versa are also common, but those containing odd number of protons and neutrons are less in common. For example, here we see the number of stable nucleides. If mass number is even and neutrons number is even, protons number is even, the number of nucleides is 166. Again, if mass number is even, neutrons number is odd and protons number is odd, number of nucleides is 8. Again, if mass number is odd, neutrons number is even, proton number is odd, then number of nucleides is 67. And if mass number is odd and neutrons number is odd and protons number is even, then number of nucleides is 53. Here nucleides means it contains element nucleus and its elements isotopes also. The 6 nucleides like C sub 6 sub 12, O sub 8 sub 16, Mg sub 12 sub 24, Si sub 14 sub 28, and Ca sub 20 sub 40, and Fe sub 26 and sub 56, which have even number of protons and neutrons, constitute 80% of the Earth crust. Now here we see orbit, shell and energy levels. So first see the orbit. It is the path through which electrons move with certain energy. Orbits are represented by K, L, M and N etc. K represents first orbit, L represents second orbit, M represents third orbit and N represent cap N represent fourth orbit. It is in a spectroscopy. The maximum number of electrons in orbit is 2 into n square, where n is the orbit number. For example, if orbit is K, it is also called shell, then it has maximum number of electrons 2 into 1 square equals to 2. If orbit is L, its orbit number is 2, so maximum number of electrons is 2 into 2 square equals to 8. If orbit is M, cap M, then its orbit number is 3, so 2 into 3 square equals to 18, maximum number of electrons. If orbit is cap N, then or N shell, then its orbit number is 4, so maximum number of electrons 2 into 4 square equals to 32. Now let's see suborbit, subshell and sub-energy levels. Each orbit excepting the first orbit is divided. The number of suborbit is equal to the number of orbits. The number of suborbit is equal to the number of orbits. They are represented by S sharp, P principal, D diffuse and F fundamental in a spectroscopy. The maximum number of electrons in any suborbit is 4n-2 or 4l plus 2, where n represents principal quantum number and l represents azimuthal quantum number. Let's see. For example, if first orbit, that is K shell or K orbit, its suborbit, there is no suborbit, so value of azimuthal quantum number will be 0, so L equals to 0. So maximum number of electrons in suborbit will be 4n-2 or 4l plus 2. From both formula we get 4 into 1 minus 2 comma 4 into 0 plus 2 equals to 2. So if it is represented by S, so we write S sub 2. Again for L cell, that is second orbit, there will be two suborbit, one for L equals to 0, which will give S sub 2, and for L equals to 1, it is P, and the value of maximum number of electrons in P subcell is 4 into 2 minus 2, comma 4 into 1 plus 2 equals to 6. So we write P P sub 6